Hi students, now we are going to derive an expression for the work done by a gas during an isothermal process. So I am going to take the isothermal process as a expansion, okay? So this process is a expansion I am going to consider. So for that the substance or the system taken is 1 mole of an ideal gas. So I have taken 1 mole of an ideal gas inside a cylinder which is provided with conducting bottom, conducting base, conducting walls and conducting piston. So all these are made up of conducting materials. So the conducting material also is called as diathermic. Okay, it is diathermic. It will allow the heat to flow from the system to the surrounding and also from the surrounding into the system. So these walls are made up of conducting material. Base also is made up of conducting material. Okay, now you will see here 1 mole of ideal gas is taken inside this container. Since the conductor is provided on all sides, there will be a conduction of heat from the system to surrounding or surrounding to system till the system is in thermal equilibrium with the surroundings. So let the initial temperature of the system as well as the surrounding be equal to what? T. Understand? T is the initial temperature of the system. And the initial pressure of the gas inside the container is Pi. And the initial volume of the gas inside the container is Vi, V initial. Now, let us say that the piston is moved upwards. The piston is moved upwards very slowly. We can pull the piston upwards, or we can allow the heat to flow through these conducting walls of the cylinder, so that when heat enters inside this gas means the piston will slowly move upwards, because isothermal process should be quasi-statically slow process, infinitely slow process. So let us take that the gas is now pushing the piston in the upward direction. So this is the new position of the piston whose area of cross section is A, and the force exerted by the piston, the force exerted by the gas on the piston is F. So that now the piston is moving through a distance dx in the upward direction. Suppose if we pull the piston upwards, then also what will happen when the gas expands by increasing the volume? Now what will happen? Cooling of the gas must take place during expansion. So what will happen? Naturally, there is a conducting environment, so heat will flow from the surrounding into the system to make the temperature as a constant. Whether you supply heat from outside and expand the gas, or if you push the piston upwards and expand the volume of the gas, in both the cases there will be a flow of heat from the surrounding into the system, and the temperature will remain always the same. But since the piston has moved in the upward direction, the volume has increased. So the pressure will decrease and the volume will increase. So P final and V final are the thermodynamic coordinates after the expansion of the gas. Initial pressure and volume were Pi and Vi. After expansion, Pf and Vf are the pressure and volume of the gas, but the temperature remains constant. Okay, so such a process only is called as what? An isothermal expansion. Okay, now during this expansion of the gas in the upward direction, the piston is moving in the upward direction through a distance dx, and during this process, what is the force exerted? What is the upward force exerted by the gas on the bottom of the cylinder? That is taken as what? F. So this force per unit area only is called as what? The pressure. Understand? Now, through a small distance dx, when the piston is moved in the upward direction, how much work is done? I am going to write the expression for that. Small work done. So infinitesimally small work done, okay, in pushing the piston, okay, small work done in pushing the piston through how much distance? Through a small distance dx. So through a distance dx. This work done also should be small, is it not? So I take the symbol dw. And dw is equal to what? Force into distance. Force into distance. And this force is also equal to what? Pressure into area. Okay, into distance. So force is equal to what? Pressure into area. Now this area is the bottom area, circular area of the piston. If you multiply this by the distance moved by the piston, means then the circular area into distance will be equal to a cylindrical volume. That is the increase in volume. So when the gas expands, by how much volume it has expanded is given by what? Area into distance. So this A into dx must be equal to the change in the volume dV. Okay, or dW is now equal to P into the change in volume dV. So this is the work done by the gas during the expansion from V initial to V final. So what is the total work done by the expanding gas from a volume V initial to a final volume Vf? Total work done I am going to find out. So this is the work done for a small distance dx. Therefore, total work done, okay, during an isothermal process. The total work done means it is denoted by W, and that is equal to integral of dW from initial volume Vi to the final volume Vf. Okay, so this is now equal to integral of P into dV, where the volume changes from Vi to Vf. Okay. Now you must very clearly understand one thing. During an isothermal process, which coordinate is constant? Only temperature is constant. What about the pressure and volume? These two coordinates both are variables because both are changing. So I have to express this pressure in terms of the other variable volume. So I will take the ideal gas equation P into V is equal to R into T. So this is for 1 mole. This is for 1 mole. Okay. So for mu moles, P into V is equal to mu times RT. So it is for mu number of moles. So in different textbooks, they are using different expressions. One is for 1 mole, the other book is for mu moles. But concept you learn correctly. Understand? So let us take mu moles also now. So PV is equal to mu into R into T. Therefore, P is now equal to mu RT. Okay, mu RT divided by V. So this is expressing pressure in terms of volume, because both are variables, is it not? The pressure also is changing from P initial to P final, and volume also is changing from V initial to V final. So instead of pressure P, I can write mu RT by V. Is it not? Because mu is constant, R is universal gas constant, temperature is a constant because it is isothermal process. So in place of P in this equation, what can we substitute is mu RT by V. Therefore this W is now equal to integral, okay, P dV. Instead of P, I can write mu RT divided by V into dV. Okay, so this is once again, okay, the limits I will write V initial to V final. So we can also write W is equal to taking the constants mu into R into T integral integral of 1 by v dv, 1 by v into dv between the limits v initial to v final. We very well know that integral of 1 by v dv is what? Logarithm, log of v, natural log or common log. Here I am going to take a natural log. So therefore w is equal to mu rt into integral of 1 by v, that is w is equal to mu into rt into logarithm to the base e, okay, v, log v. So log of v between the limits v initial to v final. So w is now equal to mu into r into t into log base e v final minus log base e v initial. This is a natural log. So we can also express this as ln. Ln means it is a natural log to the base e. So this is now equal to mu into r into t. Log a minus log b is also equal to what? The log of a by b. Is it not? Log of a by b. So into log base e v final divided by v initial. So this is the expression for the work done. This is the final expression for the work done during an isothermal expansion. And in place of log e we can also write this is equal to mu rt into ln. Okay, log base e is also called by other name, that is ln. So this is v final divided by v initial. So in some books they are using the symbols v1 instead of v initial and v2 instead of v final. So for that mu rt into ln v2 by vn, is it not? Okay children, now I am going to express this in common log. In common logarithm, in common log means what? To the base 10. This is natural log is to the base e. So in common log if I express, therefore what is the w is equal to, I have to multiply by a constant 2.303. When I change this natural log into common log, by what constant I should multiply is 2.303, that's all. Into the other factors will be as it is mu rt into log to the base 10 v final divided by v initial. So this is the final expression for the work done by a gas during an isothermal expansion. During an expansion, work is done by the system and hence this work done is positive. Understand? So W is equal to mu RT into ln Vf by Vi, or W is equal to 2.303 multiplied by mu RT into log base 10 Vf by Vi. Have you all understood? I hope you must have understood well. Fine.